Hi everyone, this is just a very quick tracker tutorial video on using tracker for the analysis of some basic kinematic motion. So first and foremost, we have to import our video. Here we will be using the example video tracker gives with its software at balltoss.mov. We'll open that up. That's okay. Now here we can see we have a ball being tossed across the frame. Very good. So first and foremost, we need to calibrate our video, tell tracker what we know. So clip settings, we want to make sure that's at 30 frames per second because that's the frame rate of the video. Very good, that's all set up, so we don't need to do anything there. Next, we want to tell tracker the scale of the video. So we can click on this guy here and get a calibration stick, and then we can shift click on 2 points of a known length. So we know that from here to here is 1 meter. So we will put that in, 1 meter, perfect. And then we can hide that as well, just by clicking there. Also, these two black arrows here show the parts of the video we're actually using. So we have a couple of unnecessary frames at the beginning of the video where the ball is about to be thrown. So about here is where we really want to start our video. So we will just drag our first arrow up to that point. Perfect. And we'll start analyzing from there. Also, we can use this guy here to set up our axes. If our video for some reason wasn't straight, we could tilt our axes to match the video, but here it's all good. We don't need to worry about that. And just for simplicity, we will set the point 0, 0 to be where the ball is initially thrown from. Okay, perfect. And we can hide those axes then again. Okay, now we're ready to start tracking. So we can create a point mass A, that's perfect. So now we can go in here and we can use the auto tracker, which is a really useful function. One of the best things about tracker, makes everything very simple. Okay, so we can see here to create a new keyframe, shift control click on the video feature of interest. So we will simply hold down control and shift and click on the ball which we want to track. The tracker's found that straight away. We can see the ball in this little template here. That's how we know everything is okay. And then we can simply hit search and it will continue looking for the ball until, yeah, see it's gone a little wrong here. It got confused with the meter stick here. So we can simply tell it this clearly isn't where the ball is, so we can simply tell it where the ball actually is by just shift clicking on the ball. And there, it's found it again. And perfect, that looks good. So we can close this and we'll just look back. Yeah, so it seems to have tracked the ball pretty good there. Every point seems to be accurate. Perfect. So now we have these graphs over here. It's really nice graphs, and we can change our value on the y-axis to be any of these parameters here, which is very useful. We can also create our own parameters as a combination of any of these. So we can look at our velocity in the x direction, which should be fairly constant, and it seems to be very short range on the axis here. Our velocity in the y direction, so we have constant deceleration as you would expect. Our acceleration in the x direction should be around 0, looks good. Acceleration in the y direction should be around -10, which we seem to have here, which is pretty good. So now that we have a lot of these initial values, what we can do is we can actually create a model and see if our model matches up with our real world ball fall situation. So we can create dynamic model. Cartesian coordinates is good. Perfect. So now we have our parameters here for the model, our initial values, and our force functions. The force functions, this is the most important thing for our model here. So in the x direction, we know we have 0 force, and in the y direction, we know we're going to have a force of mass times gravity. We haven't defined gravity yet, so just in parameters here, we will just put in g, equal to minus 9.8. Perfect. And then if we look back here, we know that our starting point is that time is 0, x is 0, y is 0, because we set our axes up to be 0, 0 at the point where the ball is thrown. And then we just need to find our velocity in the x direction and our velocity in the y direction. So we can go back to here, we can go velocity in the x direction, switch back to our mass A, and we see that it's around 1.7, so we will put that in. And then velocity in the y direction, you can see that it's just over 2, so we'll just put in 2 and see how well that matches up. Now let's just click through the frames here, and we can see they're both red, so just to make it a little more clear, we'll change the color of the model to be blue. Okay, we can see here that our model is actually falling a bit short, so it looks like we just may need to increase our initial velocity in the y direction, maybe 2.5, maybe a bit more, 2.7. Let's see how that looks. Yeah, that looks a lot better. So we'll just let that play through. Yeah, and the model and our actual auto-tracked ball seem to be lining up pretty nicely, which is exactly what we want to see. And then we can analyze our situation here, so we can right-click here, compare with our model. Perfect, okay. And we can see that velocity in the y direction matches up very nicely. Position versus time, as we'd expect. That's x position versus time, y position versus time. Get a nice parabolic curve here. As we'd expect, acceleration in the y direction, our model is going to be perfectly constant because it's the model, and then our tracked version is going to be hovering around that point, which looks good. Yep, so this concludes our basic tutorial on getting started with analyzing basic kinematic motion in Tracker. Thanks for watching.